Hello! In this video, we present the retrosynthesis of Vonoprazan, a drug belonging to the class of potassium-competitive acid blockers. The key step in the retrosynthesis is based on an atom transfer radical cyclization reaction used to prepare the ring of pyrrole from a dichlorinated allylimon, as we will see later on. Initially, through a functional group transformation, the secondary amine present in one is protected to prevent its undesirable participation. In the protected amine, too, X can be a benzyl, formyl, or ethoxycarbonyl group, among other protecting groups. A nitrogen-sulfur disconnection in 2, based on an N-sulfonation reaction, generates pyrrole 3 and sulfonyl chloride 4. The amino group on the side chain attached to the pyrrole can be introduced through a nucleophilic substitution reaction of the chlorine atom in compound 5 by the nitrogen compound 6, which arises as a raw material. The pyrrole 5 has as a tautomeric form, pyrrole 7, where the double bond between the carbon atoms can be obtained by an elimination reaction of the chlorine attached to the heterocycle in compound 8. The relationship between the two chlorine atoms in 8 and the presence of the nitrogen heterocycle suggest for its formation the atom transfer radical cyclization reaction, abbreviated as ATRC. With this idea, a carbon-carbon disconnection generates the dichlorinated allylimon 9. And two carbon-chlorine disconnections in 9 generate intermediate 10, and a carbon double-bond nitrogen disconnection in 10 generates fluoroacetophenone 11 and allylamine 12 as a raw material. The methyl ketone in 11 acts as a retrone, and a carbon-carbon disconnection leads to acid chloride 13 and methyllithium as raw material. A functional group transformation in 13 leads to benzoic acid 15. Based on a carboxylation reaction with carbon dioxide, a carbon-carbon disconnection in 15 generates orthobromofluorobenzene 16 and carbon dioxide as raw material. The fluorine atom in 16 can be incorporated into the benzene ring through the substitution of an amino group based on a Sandmeyer-type reaction. With this idea, a functional group transformation produces orthobromoaniline 18. The possibility of regioselectively brominating aniline 19 converts it through a carbon-bromine disconnection into raw material. The chlorosulfonyl group in 4 can come from sulfonic acid 20. And a carbon-sulfur disconnection based on a regioselective sulfonation leads to pyridine 21 as a raw material. In summary, the main disconnections are shown here. The resulting synthesis will be presented in the next video.